So this is the notes for 1.5. We're going to be working specifically with quadratic equations. You know it's here's a link to a video you could watch if you want a little bit more instruction, you want a little bit more help. Here's another link that might take you to places you could find some good resources, some good help. But right here, when we talk about quadratics, we're talking about something that looks like this: ax squared, bx, and c. The x squared, when I'm highlighting that, I just want to make sure we understand this has to have an x squared in it. Coefficients are the numbers that are in front. For instance, 2, 3, and 4 would be our a, our b, and our c. A is always with x squared, b is always with a plain x, and then c is always just a single number. A and b are, of course, coefficients. C is a constant. The one factor that identifies this as quadratic is the piece with the exponent of 2. So this is what makes it quadratic. The rest of it is extra stuff, but it's got to be x squared, which means, of course, a cannot be 0. If a is 0, this goes away. So that's an important piece of the puzzle. When we're going to solve quadratics, there's a few different steps we can go through. One of the biggest options is to factor. Factor into two binomials. That's something that we've done a lot of and we'll look at down here, because we know that if a times b is 0, then either a or b has to be 0, potentially both. And so when we factor these equations, like this first one, we're going to factor it into binomials. So we'd have x and x, that gives us our x squared. Factors of 10 are 1 and 10, or 2 and 5. In order to add up to 7, we're going to go with plus 2 plus 5. Now this property here says that if this first thing is 0, then I don't care what's over here. And conversely, if this is 0, then I don't care what's on the left. Either case is 0, I'm going to get 0 as a result because it's multiplication. So I'm going to look at these separately, at least this first time. X plus 2, I'm asking when would it be 0? And x plus 5, I'm asking again when would it be 0? So I'd minus 2 to solve for x, and x would equal negative 2. Over here I'd minus 5 to solve for x, and x would equal negative 5. Now you might be able to remember the rules. Hey, if it's just a plain x, we're just going to minus the sign. We're going to change the sign, and we're going to get our answers. So we've proven that if x is negative 2 or x is negative 5, we're going to get a 0 here. And sure enough, if you plug it in to the original problem, negative 2 squared plus 7 times negative 2 plus 10. Let's see what happens. Negative 2 times negative 2 is 4, plus 7 times negative 2 is negative 14, plus 10. A 4 and a negative 14 is negative 10. Negative 10 plus 10 is 0, just like I was supposed to get. So factoring is a pretty quick and easy way to get to the zeros or the solutions right away. Sometimes it won't factor that well. It won't factor the way that you would have the two binomials. For instance, this question, it's missing the c. So c must be 0. Okay, so we're missing our c term. So, what might be easier is to just look at this and say what's common. And if you look at it, they both divide by 2x, meaning that in the parentheses left behind, if I think about factoring and multiplication, distribution, I'd have to have a 2x here, because 2x times 2x produces the 4x squared. But then I'd have to have 2x times what gives me a negative 2x? That would be a negative 1. Well, now I want to look at this piece, and I want to look at this piece separately. There's those two parts. So when 2x equals 0, if I divide by 2, I get x equals 0. Now, anytime there's an x out here without a plus or a minus with it, that one will result in an x equals 0. Okay, that'll always happen. Over here, though, some of you might think the first thing to do is just, hey, it's positive 1. X equals 1, because Mr. Welch said to switch the sign. But when there's this guy over here, we can't forget that we have to divide by it. So it's actually 1/2. And I'll show you what that looks like over here. 2x minus 1 equals 0. First step, be to add 1. That's the sign change that we did to make it a positive 1 in the first place. But now I get 2x equals 1. The last step is to just divide by that coefficient of x. So sure enough, that gives us 1/2. If I look down here at the next problem, very similar question. They both have a 3x. That leaves me with x, because 3x times x is 3x squared, and 3x times 3 would be 9x, with a minus there to make it negative. Well, this, remember, when it's out here without a plus or a minus, always results in x equals 0. And this, of course, we say what's the opposite of the thing grouped with x? Would be 3. Those would be our two solutions. So factoring in some way, shape, or form seems to be pretty quick and easy. There are some, though, that don't look quite like that. And so one of the things we have to remember as we do these processes is that you always want to start with the equation equal to 0. Okay? And so as we start this, first thing I want to do is add this 4 over. It's no good if I leave it on that side. So we're going to have x squared minus 5x plus 4 equals 0. And now I'm going to start trying to factor as best I can. I'll get an x and an x. Factors of 4 that add up to 5 would be 4 and 1. And then I just think, okay, the 4 is positive, so the signs have to match here. But in order to get a negative 5, I'd need negative 4 and negative 1. Well, that would mean that x would equal a positive 4, or x would equal a positive 1. Those would be the values that would produce 0. Down here, very similar question. We've got 2x squared plus x, but I need this 1 to come over because I want it to be equal to 0. So minus 1 equals 0. Two parentheses. I'm going to go with 2x and x. Now 1 has to factor as 1 and 1. The issue here is pretty much just the signs. This is a negative 1, so I know one of them's positive, one of them's negative. This gives me 1x. This gives me 2x. In order to get a positive x when I'm done, I want the 2x to be positive and the 1x to be negative. So that's a minus 1. This one's, of course, really easy. X equals negative 1. This one's a little bit trickier, but I want you to think about it. Right now it's negative. We know the sign is going to change, so it'll become a positive 1. And then we have to divide by this 2. So divided by 2. Those would be our two answers, negative 1 and positive 1/2. Well, sometimes we look at them and you know what? It's actually a little easier to do it differently. Now, this first one, it does factor as a difference of squares. It's x plus 10 and x minus 10, which turns out to be x equals plus and minus 10. A negative 10 from over here and a positive 10 from over there. But there is another way. When the b term is missing, when you don't have bx, because b is 0, you could set x squared equal to the value. You could get it so that x squared is alone. So I would do that by adding 100. So this equation would then say x squared equals 100, and then I could take a square root. But when you take the square root of both sides, you have to insert a plus or minus. If you're the author, you must have the plus or minus. Well, what is the square root of 100? Well, that's 10. Another example down here. If I divide by 4, x squared equals 5. This is not one that has a square root, so when I take its square root and put the plus or minus in, I'm just going to say that x equals plus or minus square root 5. That's not one that would have factored well. Okay? And this last one looks a little weird. There's actually two ways to do this problem. One, I could FOIL this x plus 5 times itself, minus the 11 over, get it equal to 0, and start over. Or, if I want to, one option is to actually just start peeling things away. Specifically, if I took the square root right now, this square would go away, and I'd be left with x plus 5. In order to do it here and make it cancel, I have to do it on the other side and put the plus or minus. So x plus 5 equals plus or minus square root of 11. Unfortunately, we don't know the square root of 11. I'd like to get rid of this 5, so I'm going to minus 5 from both sides. So x is alone now. We always are going to put this constant value in front of the plus minus, so we don't lose track of it. So we're going to go with negative 5 plus or minus root 11. And there's our answer. That might have come out a little funny with the square root still in the answer. Some's real, some of it's a value like 5, and some of it's inside the square root. Might seem a little funny, but it works itself out. Now, our catch-all, the thing that's going to fix everything when we struggle, is the quadratic formula. The quadratic formula, of course, is negative b plus or minus the square root of b squared minus 4ac all over 2a. And that formula is going to be so important to us because it's going to be fundamental to how we solve these equations. Anything, even the factored ones, can be solved using the quadratic formula. Okay, and so this is the catch-all. And so if nothing else seems to work, go here. Or if you'd prefer to use the quadratic formula and not have to do more than one method, feel free to use the quadratic formula. So here A is 2, B is negative 6, and C is 1. And using the formula, I'll say negative B. Because B is negative 6, negative B would be positive 6, plus or minus square root. B squared, this is where a lot of people get into trouble. It is negative 6 squared, but you must use the parentheses. If you do not use them, the calculator will produce a wrong answer. Minus 4 times A, which is 2, times C, which is 1, all over 2 times A, which is 2. Now I'm going to use my calculator to help out with this a little bit. I'm worried just about the square root for right now. So I'm going to type in parentheses, negative 6 squared. Now I know that's 36, so I could have just typed 36 if I wanted. Minus 4 times 2 times 1 equals, I get 28. So this becomes 6 plus or minus root 28 all over 2 times 2 is 4. Now do not get carried away trying to reduce here first. We always focus on the root, okay? 28 is made up of a 7 and a 4, and a 4 is made up of a 2 and a 2. To get out of a square root, it takes 2 of something, and there's a leftover 7. So this is going to be written now as 6 plus or minus 2, that's this guy right here, root 7 all over 4. Now, if and only if all three of these guys reduce, we reduce. If they don't all reduce, we stop. These all reduce by 2, making it 3 plus or minus 1 root 7 all over 2. Okay? And there's our final answer. All right, now you might want to know, how many answers am I going to get? Are they going to be real? Are they going to be imaginary? Questions like that, they do come up. We have what's called the discriminant, which is the piece that's under the square root. If you look at the formula, in the quadratic formula, b squared minus 4ac. If that's a positive value, okay, like in this problem that we did just here, I've got 3 plus root 7 divided by 2, and I have 3 minus root 7 divided by 2. So this means I'm going to get 2 different answers. And that's what we see whenever b squared minus 4ac is greater than 0. In other words, when it is positive. From time to time, and that's what the graph looks like. We're looking for those 2 points. From time to time, the inside of the radical, inside of the root, becomes equal to 0. And when it is equal to 0, you'll notice that there is only one answer. That's because plus or minus root 0, you can add root 0. The square root of 0 is 0. Adding 0 or subtracting 0 does nothing to the problem, so it's actually not important. You'll end up with negative b over 2a is what you'll end up with as your answer, which should seem familiar because that's the vertex formula for finding the vertex of a parabola. And then when we have a case where the answer is negative, the square root of a negative 10, well, that's going to be imaginary. And so even with the plus or minus, any answers that come out would have to be imaginary solutions. And they would come as a pair, but we're not going to talk about those right here. We're not looking for those imaginary solutions. We're going to use the discriminant real quickly to tell what kind of answers we're going to get. And so all we're focused on is b squared minus 4ac. We want to know, is it positive, negative, or 0? So here, b squared, I'm just going to do this real quickly. This is negative 8 times negative 8 is 64. minus 4 times a, which is 4, times c, which is 1. That's 16. 64 minus 16 is 48. That is positive, okay, which means you'd have 2 solutions. And they would be real solutions, okay? But all we're really looking for is that there are 2 solutions. Down here, if I do it again, b squared would be 4 minus 4 times a, which is 3, times c, which is 5. This is 4 minus 12. 4 times 3 is 12, times 5 is 60. This turns out to be negative 56. Now, because this is negative, I will have no real solutions. What I have are 2 imaginary solutions. Okay? So if it had been 0, we decided we had 1 real solution. All right. Good luck. Hopefully that's enough to get you through there, and we'll see you in class.